Amit, can you please switch off the slide? And I would request Joseph Soni sir to welcome our guest, our expert speaker for today, and we will continue with our sessions. Joseph Soni sir, please.
Okay, sir. Thank you. Today we have with us an eminent professor, Dr. K. Srinivas Reddy. Sir has obtained his PhD from Indian Institute of Technology, Delhi in Energy Studies in 1999. He then joined National Institute of Technology, Warangal in June 1999 after a brief service of about 4 years at NITW. He joined IIT Madras in April 2003 as assistant professor. Presently, Dr. Reddy is Professor of Mechanical Engineering at IIT Madras, and he is also an honorary professor at University of Exeter, UK. He has also served as an adjunct professor at CEERI, CSIR, Chennai during 2014-17. Professor Reddy is a fellow of National Academy of Engineering, and he is a specialist in renewable energy with special research interest on concentrating solar power, solar efficiency, and environment. He has 9 patents, 4 granted applications, and more than 280 publications with more than 6,000 citations, an H index of 43, of which 160 papers in reputed international journals, including 5 review articles on solar energy systems and energy storage. He has co-authored a book on sustainable energy and environment, a clean technology approach, published by Springer, and the book chapters on solar energy systems are popular among energy environment community. In recognition of his research work, Dr. Reddy received awards such as WSSET Innovation Award, the Mid-Career Level Institute Research and Development Award, IRDA, Sri J.C. Bose Patent Award, and twice the Bhagya Lakshmi and Krishna Iyengar Awards. He has also won Career Award for Young Teachers from AICTE in 2003. He served as a member of Board of Governors, IIT Tirupati during 2018 to 21. He is an expert committee member in various selection review committees and visitors nominee for IITs and NIITs. As a part of human resource development activities, he supervised over 200 UG, PG, and PhD students. Most of them are well placed and working now in prestigious organizations. He organized several national and international workshops on advanced renewable energy technologies. So now I hand over the session to Dr. K. Srinivas Reddy, sir. Please, sir.
Okay, thank you very much. Thank you very much. Can you hear me?
Yes, sir.
Yes, sir. Yes, sir. Audible.
Okay, give me just 1 minute. I think there's some problem. I think so you can see that, isn't it? My slides, can you see that?
No, sir.
Oh no, just 1 minute, I'll let you.
No, perhaps it may take few seconds.
Okay.
Not displayed yet, though.
Some problem is there.
Sir, no issue. Take your own time.
Okay, just it's coming, I think.
Yeah. No issue. No issue.
So can you see your presentation in the tray, open
Yes,
share tray,
okay.
and can you see your presentation in the tray?
Yes, yes, 1 minute. Mm. It's not, you can see that.
So have you opened your presentation on your screen?
Okay.
Okay, so once you have opened your presentation on your screen, then you come back to Microsoft Teams browser, and from there, there is an open share tray. If you will click on the open share tray, it will show you your screen. Right, so you can select that screen, and from there you can go on to your presentation, sir.
Open tray screen and can you see that now?
Yes, sir. Yes, sir. Yes, sir. Now we can see, sir.
Oh, so.
So perfectly we can see.
Huh?
Yes, sir. We can see, sir.
Yes, yes,
Yes,
we
sir.
can see, sir.
Okay.
Perfectly. You can make it full screen if possible.
Yeah, it's full screen.
Press
Sony sir, it is
F5.
full screen, sir.
Okay.
Press F5.
Thank you very much. Thank you very much. At the outset, I thank the organizers for inviting me for this talk. I'll give some glimpses of mm, solar thermal system for sustainable development, mainly as part of this program, Buried Energy for Conservation and Energy Management. But I think there are some energy management aspects also we discuss here. If you look at the present scenario, we are facing several problems, and if you list out top 10 problems for next 50 years or 5 decades, energy, water, food, environment, poverty, terrorism and war, diseases, education, democracy and population. But energy cannot be addressed in isolation. So therefore, energy will always be with the environment because it has its effect on environment. So any energy consumption will have impact on environment. So therefore, energy and environment will go together, and the top three problems: food, water, clean energy, are very important. And apart from that, the energy consumption can solve most of these problems, and the world's energy consumption is rapidly increasing, and it is exponentially increasing. Mainly, predominantly, this is fossil fuel based energy scenario. So therefore, environment will have a severe impact. Will So therefore, the standard of living of any country depends on the energy consumption. So therefore, energy consumption is very important, and one of the aspect is you mentioned the buried energy. That means the energy which is mainly for space heating and other applications. But now I'll mainly focus on the renewable energy, mainly solar energy, how we can use it for heat, mainly space heating and cooling applications that we'll discuss as a part of this course. Then before that, we should know what is this energy and how is it coming and what is the major issues with these energy sources. Energy sources can be broadly classified into two categories. One is celestial or income energy. This celestial or income energy, which is reaching to the Earth's surface or from the outer space. So therefore, that's why it's called income energy, or which is coming from outer space. That's why it's celestial energy. So income energy includes solar, lunar energies, which are non-depletable, and electromagnetic, gravitational, particle energy from stars, planets, and the moon, and also potential energy of meteorites entering into the Earth's atmosphere. These are generally referred as, but what we look at majorly for energy conversion is solar energy, and of course certain extent lunar energy. But the capital energy which is already existing on the earth is very geothermal energy and atomic in the form of fossil fuels as well as nuclear energy sources. I think this program is mainly for low level geothermal energy. Initially, I thought of covering that geothermal in detail, but solar energy, how to use solar energy for both charging and discharging of the energy and energy conversion. So if you look at these sources is transformed into reserves, and energy reserves of the earth can be divided into four categories. One is a renewable or non-depletable source, which includes solar, wind, biomass and ocean. Fossil fuels, coal, oil, natural gas, and nuclear. The nuclear can be any form like fusion or fission, any one of these forms. If you look at energy system hierarchy, the energy sources are transformed to carriers and then for subsequently used in equipment. So therefore, there are wide ranges of energy sources. Mainly, as I mentioned, fossil fuel of these and coal, oil, gas, and then biomass, nuclear, and renewables, and they are transformed into high level or high end use efficiency liquid fuels or electricity, which can be used for any applications, either mobility or consumer science or building any activity. So therefore, this is the process of transformation of energy and utilization of energy through energy system hierarchy. As I mentioned that the fossil present energy scenario is fossil fuel driven, so therefore there is adverse effect on environment also. But how the technological challenges mainly for greenhouse gas concentration in the atmosphere is there's no single policy can address this problem. There are different regions, resources, markets, preferences, scale up requirements, technology timings and infrastructure. And if you look at that, there are various technological and other aspects. Those includes energy efficiency in vehicles, biofuels, hydrogen fuel cells, and so on. Then the buildings, net zero emission buildings, industrial efficiency, combined heat and power, nuclear power generation, for carbon sequestration, and advanced grid like advanced power grids and biofuel, sun power, renewable energy, various forms. So because it's not a single solution, technology solution can serve our purpose. So therefore, it's important to have a comprehensive energy system analysis is required. So therefore, it can both bridge the gap between energy demand and supply. Not only that, the environmental concern will also be addressed through a comprehensive approach. So therefore, it's important to stabilize the greenhouse gases. Then if you look at the global energy potential, we have fossil fuels like coal. If these are represented in circles, you can see the coal, uranium, oil, gas, and wind, biomass, hydro, geothermal, and wave, tidal. And this is the one, the present energy demand consumption. And this demand can be fulfilled by various sources like this, but most of them are finite source, and they exhaust because these are finite numbers. They may exhaust in due course. So therefore, there is some inexhaustible. You can see the bigger circle of solar radiation, solar energy, which is much, and it's a renewable and it's inexhaustible. So therefore, it can meet indefinitely for the present world's energy consumption. So therefore, it's important to utilize the renewable energy for the energy consumption. And if you look at the energy demand and prosperity across the world, this is represented by night lights, and wherever it's highly illuminated, it's more energy demand and more prosperity. In some areas, less energy. As I mentioned, the energy consumption is one of the indicators of the standard of the living. So therefore, wherever we have more energy consumption and more affordability, then there is a more wealthy and more prosperity. So therefore, you look at these, some areas highly illuminated, some areas less illuminated, and so wherever this less illumination is mainly uh, energy poverty, not prosperity. So there are some, you can see in this map, some countries are missing, and whatever countries are here is, and if you look at this area, uh, mainly in this area, a lot of almost 1.6 billion people have no access to the electricity, and 80% of them will be in this area. But if you look at narrowly these SAARC countries, a lot of population, several million people still use for biomass as their primary energy consumption or energy requirement. Still several million people do not have proper access, quality access of energy. So therefore, it's very important to come up with a sustainable energy. Energy sustainability is very important. As far as India is concerned, we import all forms of energy sources like coal, oil, gas, and coal is, though we are large, India is a large producer, fourth large producer of coal, but still we import coal because of the quality of coal. Now, most of Indian coal thermal power plants are importing the coal from Indonesia, Australia, and South Africa. Apart from the coal, another important energy is oil, gas we import, nuclear we import. So the energy sustainability is important. In fact, almost more than 75% of the oil is imported. So once the oil is imported, the oil is primarily meant for mobility application like transportation. So we feel that we need this transportation. So we feel that this technology, mainly you look at the cars now, you name any car in the world, they are available in India. If you look at 20-25 years back, there were hardly one or two car companies. Now car companies are many, and most of these cars are car companies are the technologies which are based on non-indigenous foreign cars, and we are consuming foreign fuel and polluting Indian environment. So therefore, sustainability is important. If the fuel we essentially land off, if you there is no fuel supply, that's we have seen that how oils are highly volatile, and mainly petrol prices are going up, and if we have a shortage of petrol, we may land up into this condition. So therefore, energy sustainability is very important, and we look at the globe, it is a bluish color, and of course it's covered with atmosphere about 15 kilometers or 15-20 kilometers, and if you consume fossil fuels, the pollutants are released into the atmosphere, and it's getting imbalanced and then getting polluted here. So because of the energy consumption, the entire Earth's atmosphere is getting polluted. You have seen that climate change and other problems, and we are literally emitting more than what it can balance or can hold it, and so therefore it's becoming imbalanced. Like we are literally burning off the Earth's atmosphere beyond the limits, and stretching beyond the capability of the atmosphere, and that's why we can see both regional, global climatic problems. Not only that, of course, associated pollution and related health conditions, health deterioration, and all this of human beings and the animals. So therefore, it's very important. We cannot load the system too much. We cannot emit the pollutants into the atmosphere. So any overloaded system looks like this. If you put too much pollutants into the Earth's atmosphere, obviously it will become imbalanced. So therefore, it's important to have energy sustainability through resource sustainability. For example, if you have resources and use them continuously without much technology, obviously these resources may become exhausted, or this resource become empty. So therefore, it's important to come up with a resource sustainability through a technology development. Then if you have a technology and we can keep the resources for the future generation, we can take the own share by this technology. So these technologies, mainly as far as the energy is concerned, is the renewable energy technology. Not this is only symbolic, but what I mean is the sustainability is important. Energy sustainability is important. So therefore, the future generation says that there is only one Earth. We have to take care of it. So I have already mentioned that the present demand is this, and then there are various fuels, mainly coal, oil, gas, and then they are catering to this requirement. And when they cater, these are finite sources. They're not; these blocks are limited, and they reduce their capacity, and their potential is reduced with this. If you the way in which we are consuming, they may be the out of reserves by these years. But in contrast to this, there is a unlimited annual solar radiation which can be available, and this can feed the demand indefinitely. And if you look at some statistics as far as the energy stocks are concerned, as I mentioned that we have abundant coal, a large amount of coal, but it's a poor quality coal, and but oil is very limited, and then coal, gas is very limited, and nuclear to a certain extent. Yeah. So if you look at that, the oil, coal, we may not see after a couple of decades. So therefore, it's very important to come up with a clean technologies. And the most important clean technology approach is renewable energy technologies. So these renewable energy technologies are primarily solar and energy. So all other renewables like wind, biomass, and other forms of renewables are manifestation of solar. Can you hear me? Am I audible?
Yes, sir. Yes,
Yes, sir.
sir. Perfectly all right.
Because I cannot see whether I am on live. Sometimes we may lose contacts. Okay, if you please let me know if you have any problem. So this
Yeah, sure,
solar energy can be utilized into different forms. One is a direct conversion, and the other one is indirect conversion. We have water power, wind, biomass, and ocean, or indirect conversion of solar energy. The other side, we have a direct conversion. The solar energy can be converted into various applications like hot water, drying, cooking, desalination, space conditioning, refrigeration, greenhouses, and power generation. But there's a direct energy conversion through photovoltaics. Directly solar energy is converted into power, electricity. So there are several technologies. Mainly, I am going to discuss some of the indigenous technology. Mainly is more they are used for sustainable development and indigenous technologies, and how the energy can be used for building sectors also, because the focus is on building sector, buried energy. So the concentrating solar power is producing high temperature heat, and mainly the electricity is produced by burning of fossil fuels like this. This coal is burnt and supplied to the heat engine. But if we replace this coal by sun's energy to produce electricity here, then it's called renewable system. And since we need high temperature, so therefore we need to concentrate the solar energy. So it's called concentrating solar power. And there are several technologies that are available to convert solar energy into high temperature heat. These are parabolic trough, parabolic dish, linear Fresnel reflector, power towers, and so on. And there are, based on the temperature, they can be classified into the CSP technology, which is into medium temperature and high temperature. Medium temperature is below 400, and it's between 400 to 100 to 400, whereas anything higher than 400 is referred as high temperature. These are technologies for both medium and high temperature. They are essentially concentrating solar power technologies. In the first category of medium temperature, you have a linear Fresnel reflector, parabolic trough collectors, and the other side is a central receiver and parabolic dish. So we are working mainly at IIT Madras on indigenous technology development, and we are working on solar energy activities, mainly concentrating solar power, solar thermal technologies, mainly design of solar thermal concentrators and receivers, and apart from that, concentrating photovoltaics, mainly integration and optimization of high performance solar concentrating photovoltaic system meant for cogeneration and trigeneration aspects. So solar energy storage and desalination are also important. The design and design of a transparent insulation material based solar integrated collector storage is one of those where energy efficiency is relatively taken into account. And apart from that, solar desalination materials for solar energy conversion and characterization of solar energy materials. And resource estimation is how to find out the energy that is available at a given location, mainly to come up with new systems at new locations, and therefore it is important to know the solar resources. This can be either measured or estimated. If it is measured, we need instrumentation. Those instrumentations are very expensive, so therefore we'll go for estimation, and estimation requires tools, and artificial neural networks is one of the important tools for estimating solar radiation. This is our lab, because solar research facilities, and we have large scale solar concentrators, and this is a parabolic dish where solar energy is converted into, if the sun as energy is there, it is converted into the energy which is falling on the mirror will be reflected here and then concentrated at this location and converted into heat. And when you circulate the fluid here, then it comes up as a hot fluid here. So this is such concentrator, and it needs to be tracked when sun moves from here to here. So therefore it requires 2-axis tracking system, and this can produce up to 640 degrees Celsius with a relatively good or better efficiency. This is a photovoltaic system with a tracking mechanism, and because it needs to be integrated. Now we are talking about rooftop systems and so on. The another one is desalination. See, water is everywhere, but we need to get the potable water, but this potable water conversion requires energy. And if you look at solar energy conversion, will become an attractive option. Either it's a brackish water or sea water, especially where I think this entire coast, Indian coast, can be used to produce pure water by using solar energy. Yeah, another concept is the parabolic troughs. It's a line focus systems, and the solar energy which falls here is reflected here, and then when you send the fluid through this, it picks up and then comes back here to the tank, and you can see that how the solar energy is reflected onto this receiver. There are two parallel system configurations. Apart from that, concentrating solar energy for photovoltaics is also another important aspect. Generally, solar cells are less efficient, so therefore the efficiency of solar cells can be improved by increasing the solar radiation onto the cells. And if you increase the solar radiation through conversion, there is a lot of heat is also produced, and that results in high temperature. And when the temperature of the cell increases, the efficiency drops. So therefore, it's important to cool the cell by the cooling mechanism. So cells are placed here, and the radius is reflected here, and then circulating the fluid through this. So this is another concept. Solar radiation measurement is important, but we can also use the tools to estimate the solar radiation. And this another view of our lab. Here is our approach is a 4D approach: design, development, demonstration, and deployment. mainly for concentrating solar energy. So it is to the demonstration scale, so therefore it can be taken directly to the field. We have some industrial associates where they have already taken some of this technology to the field. And if you look at, this is one such concentrator, and it's made of mirrors. The radiation from the sun comes here and gets reflected here. So this is a collection receiver which collects the energy from reflected radiation here, and subsequently it's transferred to the working fluid and it is taken back. So this requires two-axis tracking. Therefore, development of cavity receiver for such high temperature and high pressure applications are very important. So therefore, we have done substantial work on solar receivers, mainly for process heat and power generation applications. So this is a dish and it rotates two-axis with respect to both elevation and azimuth, and then we can circulate that. This this is a typical photograph of that, and then receiver plays a major role. This plays a major role here, and mainly for solar thermal conversion. Otherwise, there is plenty of heat losses to the atmosphere. So therefore, the losses from the receiver can be essentially important activity for performances. So study of the system. The various considerations are taken as thermal walls and adiabatic walls, and then we used for superheated, heated and saturated and subcooled conditions with respect to temperature and pressures. And it has a wide ranges of applications, like superheated steam can be used in power generation, saturated steam is in food and textile industries, and subcooled system is a pulp industries, mainly air conditioning applications and the paper and pulp industries. As you know that this program is on buried energy, which can be used for space conditioning. Similarly, the solar energy can also be used for space conditioning application. Then we did a lot of numerical studies. I don't know how many of you follow that. Mainly development of receivers and analyzing convection and radiation heat losses by using computational methods, and then you can see the distribution of temperatures, fluid flow and so on. The fluid flows enters here and then comes here and then comes here and then goes back as a high temperature heat. And we use neural networks to estimate the overall performance of these receivers based on the construction thing. And there are several receivers have been studied, and mainly for optimizing this based on the heat transfer and overall performance and heat collection point of view. And there are essentially three receivers: cavity, semi-cavity and modified cavity receivers have been tested. And modified cavity receiver, because it has to be tracked continuously from morning to evening, so the heat losses are different from morning and noon and different, and so therefore it's very important during tracking to estimate the heat losses. So mainly it is designed from the accurate sharp dish to the fuzzy focal dish, and then it's a wide angle reflection. So the receiver plays an important and mainly collection of solar energy, and it should produce converts maximum energy from solar energy and with a minimum losses. So therefore that's an important aspect of that, and its geometry, orientation, temperature, wind speeds play an important role, and modified cavity seems to be more efficient than as compared to the others, and there is a detailed analysis has been carried out for heat losses and so on. So the average, these are mainly non-dimensional this one, and we studied with the different heat losses in different orientation, because the heat loss to the environment will have different configurations. That means it dynamically changes as the location of the receiver is concerned. So it has been estimated and then found that wherever the higher losses are involved, they can be avoided by appropriate designs and so on. it can be placed in a large scale field, like where, see, we are now planning to use this dish collector system mainly for space conditioning, geothermal, in Ladakh and Leh region. I think recently we got a project to produce heat, so that that heat can be used for space, like building space conditioning, and can also use for cooking application, and also used for food dryer. Like they have mainly in Ladakh region, this apricot is there, the drying of fruits also very important. So solar energy produced by this type of dish collectors can be used for these applications: cooking, drying, and space conditioning. I'm not going to details of this mathematics, because if one system, because we cannot go for infinite size of the system, it is a finite. So, but if you want to go for large scale power plant, it needs to be our energy system. It needs to be connected in the field. So, when you have field, there are several, because several dishes um, are surrounded by the, if you consider this dish, and there are several 8 dishes are surrounded by that, and when the sun moves from east to west, and it will be covered, and there's no energy coming. So therefore it's important to have appropriate space between them. So that space analysis has been carried out from Kashmir to that Kanyakumari to Ladakh region, and it is tabulated for power generation, and we came up with a viability of that, wherever we developed an atlas for this power generation across the India, and wherever these green locations are there, they are commercially viable, and with the present technology. Blue ones are conditionally viable. Red one is not available with present technology. In future, it may become viable. So we have to find out estimation of these losses from the modified cavity by different methods. Mainly the natural convection, forced convection plays a major role, and we need to find out how this will play a major role on dependent on the temperature, and compared with the ANN network and artificial neural networks. So there are several losses involved here, and then head-on losses, side-on losses, and those losses need to be predicted by the estimations, and then we have to see it will vary from time to time, from 0 degrees to 90 degrees and so on. Forced convection heat transfer is sometimes is predominant, mainly when they are saturated and superheated conditions. So it's important to study explicitly how the behavior is. Then the receiver is very important, because it is the heart of the system. So receiver should collect the maximum energy with minimum losses, and there are metallic tube collectors, receivers, and there is different sizes of the concentrators, receivers, and length, how much length we need to use, and so on. A typical concentrator looks like this, with a monotube boiler concept. And we can look at closely how the gridding and grid generation is done here. So the heat transfer through helicals, it goes here, as I mentioned here, and then comes out from here. So therefore, heat transfer studies are very important with respect to the flow conditions. And these are 3 different conditions where the low temperature hot water is circulated in the boiler and producing saturated or super heated steam. And that is with this dish, as I mentioned, that the dish can be, the steam can be used for space conditioning, and it can be stored underground with energy storage. That's what the topic is, buried. You bury the energy and you take it whenever you need it. So another technology is a single axis tracking system with a parabolic trough collector, and as I mentioned, the radiation is reflected onto this receiver. If the radiation is coming, it is reflected here, and it's a single axis tracking and continuously rotating. This is a very important thing. We can go for process heat and power generation application for large scale. This is installed in our lab at IIT Madras with a heat exchanger network, and here receiver plays a major role in this. It's a enclosed receiver, absorber coating, vacuum, and glass envelopes, glass to metal seal, absorber stability plays a major role. It's a important component, so it needs to be developed indigenously and used for local conditions, because they have their own issues like absorber coatings, vacuum, and glass envelope, glass to metal seal, absorber stability, and several aspects need to be studied while doing this. So we can use this is for process heat application, as one of the process heat applications is space conditioning and power generation. You can see we do the detailed optical analysis how the ray is moving from sun to the target, and that needs to be tracked to find out the flux distribution in the receiver. So there are various technologies. Some of my students worked on this to produce effective heat transfer mechanism in the receiver, and for that there is a porous receiver configuration was proposed, and then we have optimized and come up with a optimal configuration of this system. This is a receiver system. This receiver will be here in this case, and the performance seems to be better for both water and thermic fluids. This is water and thermic fluids, but it needs to be studied thoroughly. And another configuration is the linear Fresnel reflector, where there are flat mirrors and the solar radiation coming from the sky, sun, and will reflect it here onto the receiver. And there are several such mirrors are placed even from the other side also. Here it comes and then reflects here like this. So this is called linear Fresnel reflector, and if you this place looks like this here, how bright sun focus onto the receiver, and there are different mirrors here. These are the different mirrors, and they focus here. And design of this receiver plays an important role in thermodynamic perspective, mainly thermodynamic analysis point of view, and their optical performance point of view. So we have come up with an optical configuration under different conditions, and depending upon the heat losses and so on. And we installed this in a school where these panels are tracked with respect to this. This is a panel, it is tracked like this, morning to evening, and this rays which is coming here is reflected here, same way, here. There are two units, and this is a energy storage. It's a more of a buried energy here in this case, and there's a phase change here. So the energy, hot energy is stored here. Here it's essentially design, development, and of a storage integrated LFR system with 50 kilowatt thermal capacity, and it at a higher temperature and pressures. So about 350 to 400 degrees Celsius. This is installed in a school here. This is a Pathashala campus close to Chennai, Kanchipuram, and it produces both heat, air conditioning, water, and cooking. All this is a power generation system. It's working in this. And we have done how the flux distribution, how the ray is reflected here. You can see here, and it's focusing here. And we need to look at this, how the configuration should be. The water should circulate through this, and then this is a radiation which comes here and gets reflected onto the receiver. And similarly, here it's a similar configuration. If you look at schematically, this represents like this. For this also, receiver needs to be analyzed in order to have a high performance and higher yield. So one of again my students has done thermodynamic and heat transfer analysis based on this, and come up with an optimal configuration of this receiver. So it's important. You can see that how the receiver distribution, when the wind is also, the wind also blows here, because this is outdoor system. It is subjected to high windy, gusty conditions and dusty, because especially in India, tough dust is accumulated. So therefore, dust plays a major role in overall performance. So we have completely studied with different wind conditions and different angle of attack and so on. Then because the solar thermal collectors requires concentrator, which may require tracking system, but without tracking, whether we can design any such system so that it will have less cost. Not only that, it will cater the low temperature and medium temperature application. So we developed the three-dimensional non-imaging elliptical hyperbolic concentrator. It looks like this. It's a elliptical aperture and hyperbolic in configuration. So this is hyperbolic configuration, and this aperture is an elliptical, this one, and the rays goes in here. And then if you look at this, it's important heat transfer studies here, and this design of this is very important. So it looks like this here. Cubes are wounded. It's wound around this, and then the inlet goes here and then revolves and it comes back as an outlet. So it's a surface receiver. It absorbs energy, but careful design is required for this. The same thing can be used for various sizes. This is a bigger size, and the radiation comes here and reflects onto this part. And depending upon the seasons, depending upon the conditions, we can find out how much energy is available for this. So this ETC analysis is substantial at various conditions, and it's one side view and front view need to be studied for heat losses, and it's found varies from 1000 watts per meter square under these conditions. And the incident angle also plays role in incident flux, temperature, concentrator flux and concentrator plays a role here. And the deeper studies has been carried out at IIT Madras with respect to two different incidence angles. Anyhow, this is the real picture. As I mentioned, that our approach is a 4D approach: design, development, and design, development, demonstration, and deployment. That's a 4D. And these are hyperbolic concentrators, and the radiation comes here. It will have to directly goes to the bottom. So therefore, it's very important. And at the bottom here, the receiver is placed, and the solar radiation can be measured by this system. And apart from that, the desalination is another important aspect, converting brackish water into potable water, or because seawater, especially Chennai, we see that the seawater converting seawater into potable water, and where the water scarcity is there, we developed multi-tray solar desalination system. It's a novel approach in which the latent heat can also be used. Typically, it consists of 4 to 5 trays. In that, the evaporation condensation process takes place by using by supplying solar heat. It looks like this. The solar energy comes here and absorbed and goes to the tank here. Fresh water you can circulate through this because it is completely insulated from the collector. So it has been studied for different stages, and then different water conditions: blackish water, and then brine and fresh water and saline water, and then it found satisfactory results, which can be used for commercial applications also. And some of our technologies have been commercialized, as I mentioned, as I indicated earlier, that indigenous technology development plays a role to give end-to-end solutions. So these are some systems which are given to the industries. They have installed in their locations, and these are brochures they are supplying commercially also. And this is a system where it's installed in Coimbatore, one of our industrial associates, And this is also linear frontal reflector. All this, you can see that there are 2 rows and they can be tracked continuously to get this. So radiation coming from the sun should reflect onto this. So the fluid is circulated. It comes from the bottom, from the tank. It goes like this and then comes back like this, and you can see here high temperature, high pressure steam. And if you look at this this you can see here is the same view here, how steam is coming out with a very great force. Another configuration, another technology in development for sustainable, another technology for sustainable development is design development of solar energy driven textile effluent treatment. Mainly in Tamil Nadu, Tirupur region is a textile hub where textile industries are getting close because of the stringent environmental norms. So it's better to come up with a solar technology for effluent treatment or arbor reject treatment from textile industry. We have come up with a configuration. You can see here this we tested here for this textile industry. So this is installed in Tirupur region in Tamil Nadu with and this is at our lab. We have tested here, and it's given solution. The solution was given to textile industry. Some of them have implemented it. Another important technology here is see, zero discharge is important from because under soil we are talking about Swachh Bharat cleanness toilet is an important thing. So we developed a solar powered zero discharge toilet. Both zero discharge means both solid and liquid, and is installed in one of our students' hostel, Krishna Hostel, for performance study. And of course later we have commercialized. And this toilet doesn't give any liquid or solid, and liquid is recycled, and some top of water is used, whereas solid is converted into fertilizer. And another important thing is the mobility. Solar energy based mobility is very important because nowadays we are talking about electric vehicles and so on. But if it is powered with solar energy, it becomes a cleaner fuel for automobiles. So there's a integrated RES means integrated renewable energy system in mobility has been implemented by us, and using different configurations and components of that. And this is a mobility, but you have other integrated renewable energy system with a battery, and integrated with the renewable means other type of renewable energy like biogas here, and used for producing electricity through engine. But parallelly solar comes here, and then it gives a feedback and gives the electricity to this. We have implemented in Vishwabharati University, that is Shantiniketan in West Bengal, this type of system. Here you can see this is a standalone system. Here the biomass is integrated with solar panels on the top here, and inside there is a generator which converts biogas into electricity and gives to the control system, and then it stores in the battery, and vice versa. It can take back from the battery and use it for the load, and depending upon how the configuration is. So before that we tested at IIT Madras by using these panels. You can see them, and with a gas conversion into electricity by using this generator. So we can integrate PV and biomass system. Here it is in our lab. I have already explained to you this mobility, how we can solar energy can be integrated in the mobility, and these are our student how this how to test this vehicle under different dynamic load conditions, as well as dynamic road conditions also, not only load but also road conditions. Then the students are doing that. And compared with a commercial auto, in terms of energy, emissions, and cost, energy, how can be used, and how it be converted, and then how, based on this, how we can reduce the emissions and so on. And it seems to be good for it has a less payback period as compared to this, and it can be adapted easily for mobility applications. So before that, I think there's some oh, there's a I think before that I will show you some buried energy systems for these. I think there's some how energy management can be used for these systems, and what are the cost implications of this system here. See, energy conservation is very important here. Energy efficiency is an important aspect here, because the environmental pollution, climate change plays a major role. So therefore, energy import, because your course is on energy conservation. Oh, can you see my slides? Hello?
No, sir. No, sir. The slides,
Okay.
it
got disconnected.
Yes, yes, yes.
Yes, sir.
Okay, just I'll reshare it.
Okay, sir.
Oh, there's a problem. Can you see that now? Can you see?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yes,
Yes, sir.
energy, yeah, energy efficiency and energy conservation and management are very important here. Then how do we come up with energy conservation? Mainly when we have environmental issues here. So then the environmental pollution, climate change plays a major role. I have already discussed various technologies that we developed at IIT Madras. The energy efficiency is a reduction of energy demand, and using energy efficiently through energy conservation, and use of sustainable energy sources such as solar, wind and biomass, and use fossil fuel as long as they are indispensable. And then energy efficiency can be attained, or energy conservation can be attained by reduction of energy demand, maximizing use of renewable energy source, and use of fossil fuels in a cleanest possible way. Then this is what a typical thing: reduce, reuse and recycle concept. Try to improve that. And energy efficiency analysis is more important through energy management, and that energy management is has to be most cost effective, energy efficient use of energy. Energy efficiency is a very important concept for energy managers, and as I think, I don't know whether you know, the first law and second law of thermodynamics we are used for evaluating the performance through coefficient of performance and so on. And there's a first law, second law analysis can be implemented. First law of thermodynamics tells energy conversion from one form to the other, and whereas the second law tells us the quality of energy conversion. There are several equations, I don't know we will follow, but it depends on the available energy. Here, available energy known as many other forms like availability, exergy, energy, Gibbs free energy, and so on. So the performance of this can be given in terms of this, and second law efficiency is given by the other, like based on the availability. And there are several performance parameters like effectiveness, which is mainly theoretical maximum available work to accomplish the available work, to accomplish the ratio, and it can also be given in terms of the other thing. Major factors for inefficiency is the mechanical, fluid friction, energy, heat transfer, and electrical energy, losses of availability. These are major causes for the inefficiency. Therefore, we need to avoid. And there's a management, energy management is important. This energy management will result in energy efficiency in industries, but it can be even building sectors, commercial sectors also. There are different phases of energy management. Energy management is defined as the art and sciences of optimizing energy, optimum use of energy to maximize the profit, mainly reduce the cost, thereby economic competitiveness. The energy managing program involves three phases, like initiation phase, the audit phase, and implementation phase. And in implementation phase, the goals are described, and capital investment is required, and application of energy management are important. So there are several formulations. I am not going into details, but here one of the important things is that the geothermal plant, which is related to this course, and apart from that, the heat pumps here, both electrically driven and air conditioners are important in case of space conditioning, absorption, refrigeration. So therefore, these are very important in burying the exploiting the buried energy with heat pumps and so on, refrigerators. There is a complex equations which are involved in mainly quantifying this energy, and mainly quality point of view, which we call exergy, free energy, availability, and SRG, all these. So energy management will involve several aspects like initiation phase, audit and analysis phase, and implementation phase. Depending on the availability of that, they are based on the various factors like audit and analysis phase, review of historical patterns, and facility walkthrough surveys and preliminary analysis, and development of energy audit plans, and conducting energy audit, cover and energy management approaches, and comprehensive historical data. Energy management, EM is energy management, will have a role in collecting the data, engineering calculations, heat transfer, mass transfer, and theoretical energy efficiency calculations, and computer analysis and simulation. These are some of these aspects we need to see, and there are different phases. The energy management general principles consist of wide principles from almost 16. It starts with a review to the economic evaluation, involving several aspects of that, substitution of materials, and then going for alternative energy sources and so on, and they have their relative merits and so on. I have listed of some of these here, and it's very important to know the cost competitiveness of that. And if you best cost competitive comparison is like, see whether to buy a Jeep or whether to come up with a solar photovoltaic system. Overall, how much energy, because the environment is important. You see that emissions in terms of carbon dioxide emissions are very high, and therefore how to offset these by using, see, if you go for a automobile, you are producing CO2 and you are adding carbon footprint, whereas if you go for photovoltaics, is a negative. So therefore it is environmental friendly. So therefore cost analysis is very important in terms of payback period, and also cash flows plays a major role here, and the time value of money is important, and making it net based on net present value, we need to arrive this, and we can find out the payback period is one of the economic indicator to judge whether the project is viable or not, and what is its opportunity cost in terms of rupees today's and tomorrow. See, the plant cost today is not same as after 10 years. So therefore, their relative present value needs to be calculated when you go for energy management. There are several options whether you go for environmental economics or energy economics. So therefore, there should be a choice whether you go for development or you take care of environment. So you want to burn the fuel or you want to save the environment. That is an important thing. and one of the important aspect is a buried energy, which is in the form of geothermal energy. Geothermal is heat that is in the earth, and but we are talking about the earth which is in still molten salt. I'll give you some glimpses here. The earth is in molten state, which is in magma and lava, but we are not going for that deep. There are several geothermal reservoirs here, and they can be volcanoes, hot springs, and geysers. This is the one you must have seen geothermal energy in this format, like this springs and so on. But what we can use this buried energy for space conditioning, mainly geothermal energy at a low temperature scale. We can use like hot springs, geysers for space conditioning and so on. And it is like this. You can see the structure, but we are not worried much about this as far as this course is concerned. It is has a different layers, but any energy which is saved at the top layers is important, and that's what we are burying the energy into this. It has a different value of that. So if you look at the earth structure, it will be like this. And there are different energy geothermal reservoirs, and in India also we have some geothermal reservoirs which can be used for our applications, which includes Oga Valley of Ladakh and so on, and there are a lot of springs, the Himalaya here and there you have shown there. How to use this energy? There are different types of geothermal regions like hydrothermal, semi-thermal, and normal, and then these natural hydrothermal circulations and hot springs, rock dry fracturing are responsible for this. And there are different types of utilizations. You can use ground source heat pump for the buried form, or direct source commercial electricity generation, depending upon the swimming pool, bath. What are the applications of this buried energy? Can be swimming pool, bathing, and space conditioning, direct heating, agri-business applications, and so on. Electricity can be generated with the different technologies, and if the temperature is greater than 1500, you have different technology, and if it is below 1500, some other technologies. There are different rates of performance of geometric reservoirs, depends on various parameters. They have listed out here 5 parameters. Here how we can see geothermal heat pumps here with the solar applications. Also we can store heat into this by burying this geothermal heat pumps from one area to another area is very important. Earth can be used as a sink in summer and heat source in winter, and store this energy by using solar energy and store it in the underground, horizontal like this or vertical like this, and remove whenever it's required for the room space heating. So here we'll have 2 well conditioner, 1 well, depending upon the availability of that. Geothermal conversion is very important here, the hydrothermal, dry rock conditions and so on. And these are water is pumped to the underground and brought it back based on the locations of that. You have like these hot springs. There are a wide variety of applications. We can send the water into the ground and recover it through geothermal, like use for power generation or space conditioning here. There are different, if you look at, we can do thermal analysis in geothermal, like how much energy is available in, how we can save into the underground and recover it. This complete analysis is there. Anyhow, it's beyond the scope of that I am giving you here. How to calculate the energy that is available in underground can be done by these equations. There are different types of structure, geological structure, and that is a dry hot system. Some equations are used. Anyhow, this is beyond the scope of this one. And there's a hot aquifer analysis also. We did it assuming that there is no interaction. So geothermal plants can be used by taking heat from the geothermal energy and used for power generation for dry steam plants or uh, flash steam geothermal plants. Mainly they are deeper, but you can use for space conditioning at a higher level. So this is another binary cycle based geothermal plant which is used for getting the heat indirectly by using circular geothermal, because there's a contamination problem, environmental problem, so that can be avoided by this application. There's a Kalina cycle. I don't know how many of you know Kalina cycle. Kalina cycle is used for space conditioning as well as power generation. Mainly, these are very useful in space conditioning where low. You see here, you can see that this area house, it can be used for district heating. Not only this buried energy can be used for district heating application and also power generation through Kalina cycle. So there are a lot of socio-environmental aspects here which takes care of that, because there are a lot of problems with geothermal energy with a low intensity other things, but some of these sources are very useful for storing as well as removing the heat from this. This again, I told you that is our approach is a 4D approach. I have already explained. We worked on the uh, solar energy systems for process heat and power generation, and based on 4D approach, we developed models, prototype, and so on. I have already explained this direct indirect conversion, and this is another sources of that. I want to show some other things here. This one you see here, this is another technology where we can convert solar energy into this. We have come up with the fourth generation, fifth generation process heat application. This is the one which is used for air conditioning applications here. This is the air conditioner, and that air conditioner is used for space conditioning and by using energy storage and so on. So this is a technology where the human waste can be converted into fertilizer by solar energy. This which we have seen here. So with tile it was developed, and this is our approach, research, demonstration, deployment approach for sustainable energy, both uh, process heat, power generation, as well as the space conditioning applications. So with this, I think I'll end my talk. I thank the organizers. If you have any questions, please feel free to ask. Thank you very much.
Sir, one of the participants, Anant Malia, has asked, were there any modifications made for generator to run? Oh, no, sorry. Just a second.
Where is that? I can see that. I cannot see the comments.
Sir, I'll tell you. One of the question is, which solar field is better in terms of techno-economical aspects for 1 megawatt solar thermal power plant at medium temperature heat source conditions?
So it's parabolic trough collector is important, is good. You are talking about technologies. Parabolic trough for 1 megawatt is good.
Okay, okay. Participants can write their questions, if any, in the chat box so that I can read out to our speaker. Yes, yes.
Joseph Soni, sir.
Huh.
Yeah,
Yes,
sir.
sir.
I have send you the questions of the participants. So if you can read them, sir.
Okay, okay, okay. Just a second, sir.
We have two questions from Anant Malia, sir, and we have one question from Samuel, sir. Right, sir? I've sent you those questions, sir.
Okay, just a second. Uh, Sir, one of the question is in zero discharge toilets, it looks like an area shaded by trees. How efficient will the system be since it is using solar PV panels?
Okay. So I think this solar actually, in zero discharge toilet, mainly the complete treatment is through thermal systems, but only the electrical energy which is required required for pumping purposes, mainly the what you can say both solid, because this toilet is completely hermetically sealed. There is no human intervention. The solid is separated, dried, and pumped up and down, and then converted into either biomass or fertilizer. That is one part, and the water which is recovered will be reused, and then there will be some makeup water. So therefore, for pumping purpose, the photovoltaics is used, and then for thermal treatment it is used these thermal systems for treatment of the both solid and liquid. So your question is because that we have to install in a hostel, that is the location the administration, the institute has given. So therefore we, and most of, I hope the IIT, because it's a reserve forest, and this is the space which is available. But what we did was some panels are placed on the roof of the hostel, like fourth floor. So therefore the electricity is taken from there, but this is only a small part. Of course, there is a shadow only mainly in the evenings and mornings, but during the daytime there may not be much shadow. But it's a location specific. The shadow is a location specific. But in this particular case, because we are asking in this particular case, that few panels are used for pumping, but remaining panels are placed on the top of the building. So it's only some narrow space is given. But if you look at on the, I think you can share. If you want, you can show you that. Can you see this? My slides are.
No, sir. You'll have to present, sir. You'll have to
No,
present
sir,
again.
no.
Okay. So here he's asking this one. You see, this is the building space used because it's on the ground floor. These are the
Yes.
panels. Can you see that?
Yes, sir.
You can
Yes,
see
sir.
this.
Yeah.
So these are the panels. But if you look at this is another thermal system. You see pipes coming here, and it goes down, because I have not given full presentation in that how it is taken back with the screw conveyors and all these. And then we see one collector is here and one more collector on the top of this building, because this building is you cannot see full building here. You see that he's saying that there is a shadow here, but this is only for minor electricity purpose. The major one is there, but this should not be there here. In this case, this is the they have given this space between the two blocks, so small place, but remaining energy is taken from the other side. Okay, that is one which I can say. And what else? Other questions?
Sir, one more question by Dr. Shyam Kamborja. What is the percentage efficiency of dish-shaped reflectors?
It is about 65%, 65% to 70%.
Okay, sir. One question has been raised by Mr. Nityam Oza. His question is, uh, what is the effect of shadow on part of solar PV panel? Does rooftop systems are taking care of it?
I think what is the effect of shadow means the effect of shadow will have a effect on current voltage characteristics. Current voltage, because if see, that shadow can be full panel, or shadow can be even a one cell also. So what happens is these cells are panels are connected series and parallel, and when they are if there are two panels are connected in series and one panel is covered with shadow and another panel is not there, and this panel will become, one panel produces electricity, the other doesn't. So therefore, when they are connected in series, it will substantially affect on the overall output. So therefore, that is one thing. If it is completely shadowed, it will have it will have some effect. But if you only one cell is shadowed, mainly what happens is, if you look at nowadays, dust accumulation is one part, and another thing is this birds. Sometimes the bird sits on the panel, and that will have a shadow on that, and even sometimes bird droppings. So a small fraction of the panel is shaded. Then what happens is, the entire current is drawn through that cell. Then it will get heated up, and there is a possibility of failure. But in order to avoid the failure, there is a bypass of this panel can happen. So rooftop systems can be okay, because as long as there is no shadow, but shadow will be only certain part of the time, not all the time.
There are two questions asked by Anant Malia. The questions are, were there any modifications made for the generator to run efficiently on biogas? And the second question is, are there any effects on the life of a generator?
Please repeat that. Any modification made to the generator? Okay, yeah. I think, there is because biogas is mainly, it's a methane, and of course carbon dioxide, carbon monoxide is there in that. And if you use a normal generator, petrol, and the biogas is altogether different, and there is some modifications. First modification is gas cleaning. It needs to be cleaned because there is a particulate matter and other things. It cannot go, should not go into the cylinder, otherwise it will have a problem. So therefore, first is a gas cleaning, and second thing is biogas is brought into the, like this biogas drums, that domes, and these domes, sometimes there may not be enough pressure to inject into the cylinder, that means generator. So therefore, there is in fact, in one case we used a small not it's a small fan. Fan means it's a small blower is used to compress the biomass into the cylinder.
Sir, one question has been raised by RB Varia, sir. His question is, if concentration of solar rays can be done on solar panel, what is the result on efficiency?
That I think I have shown some concentration of solar. See, as I mentioned, that solar panel is about 15 to 16% efficiency. Remaining is lost to the environment. But if you want to increase the efficiency of the collector, you can put more solar energy onto the panels. But how do we do that? We can concentrate solar energy onto the panels. Hello? Can you hear me?
Yes, sir, please.
So once you put more energy onto the panels, what happens is the panel conversion efficiency is higher, but not only higher, but also its temperature will go up. So in India, atmospheric temperature in summer itself is 50 degrees. Then if you, so therefore, because of this high temperature, what happens is the panel efficiency drops. So therefore, one way of avoiding that is you remove the heat from the panel, both actively or passively. Actively means you can circulate water to the bottom of that or some fluid to recover heat, and that heat can be used for some other applications. In fact, some of our industrial associate they did it. And not only that, there can be a passive way by adding some heat sinks, so that the heat can be removed, but the panel is operated at low temperature with a high concentration. So the overall efficiency can go even up to 40%.
Thank you. Thank you, sir. So one more question is by Narendra Singh Parmar. He says, on a solar rooftop system without tracking, can use reflector system to impose rays on sun on solar PV?
Yes, without tracking we can do it. That without tracking, it's called CPC, compound parabolic trough, because tracking requires some extra energy, and whatever energy gained by tracking should be more than the what we invest or what we spend in tracking. So therefore, sometimes it may not be viable. In such case, we have to go for non-tracking type of systems, in which the CPC, compound parabolic concentrators, are used with low intensity, low concentration ratios. So it is possible.
Okay, sir. Thank you, sir.
Over. All are over.
Do we have any more questions from participants? I think sir has satisfactorily replied to all the queries of the participants.
If you have any questions, please drop me by email, so I can also respond to that. No issue. I think this is a very odd time. I don't know whether you had your lunch or not, but it is a very odd time for. I think some of you are hungry. You have to see.
Okay, sir. On behalf of BBIT family and on behalf of all the participants, I would like to express my sincere gratitude and thanks to Dr. K. Srinivas Reddy, who has enlightened us with his interesting topic on solar thermal system for sustainable energy. The information shared was too good and too much in depth. Few concepts were beyond our imagination. Maybe we had some gray area, but we were happy to know newer areas in solar thermal systems. Sir started presentation with the top 10 problems for next 50 years. He discussed about energy sources and energy reserves, the technology challenge scenario, energy demand and prosperity. He gave a lot of information on sustainability, global climatic conditions and loading resources. He gave so much of information about solar energy activities which is being carried out at IIT Madras and solar power technologies. In and all, I can say it was very, very much informative session, sir. We are indebted to you, and we hope if there are any questions from the participant, we will email you, sir. Thanks a lot once again, sir, for accepting our invitation and doing this a wonderful job. Thank you, sir.
Thank you. Thank you very much. I'm exiting from there. I'm signing off. Is it?
Okay, sir. Okay,
Yes,
sir.
sir.
Thank you, sir.
Thank you very much, sir. Thank you very
Yeah,
much, sir.
thank you, and all the best for the rest of the sessions.
Thanks a
And
lot, sir.
thank you.
Yes, all the participants are requested to please cooperate. We have a strong and enough connectivity from our side. So please please check your connectivity from your side and sit to near the good connectivity. And if you have any problem, please kindly contact to our organizing team. So please be cooperate. We are not strict. We are just follow the AICT guideline. Please cooperate. Now we will next session on 3 o'clock. So please we connect at 2:45. So thank you very much. Thank you all. Please.